So we talked about properties of ionic compounds. We talked about its melting point, why it was so high. So now we're going to talk about, are they conductive? So can ionic compounds conduct electricity? So before we talk about ionic compounds in general, I want to talk about what does it take to conduct electricity. So this is a really important little bullet point. So to conduct electricity, you have to have two things. Okay? The first thing you have to have are charged particles. You have to have some sort of charges somewhere. And the second thing you have is you have to be able to flow. So you have to have charges and you have to be able to flow. That's the only way that you're going to be able to conduct electricity. You have to have charges and they have to be able to flow. So now let's talk about if it's an ionic compound. So an ionic compound, say NaCl, remember if it's written like this, it's really Na, cation, chlorine, anion. Okay. And we'll talk about how do I know it's a +1 and a -1, but remember we talked about if it's group 1, they make +1s, and if it's group 7, they make -1s. So remember we can predict charges. So even though it's written like this, remember that it's an Na, it's a cation, and an anion hanging out. That's the definition of ionic compounds, because they make ions. So that means that no matter what, if it's an ionic compound, I automatically have charged particles. So ionic, you automatically have ions, which means you have charged particles. So this whole part 1, needing charged particles, is a given. Because if it's ionic, we have charges. So the second thing is this whole flow issue. So if I'm a solid, so if I'm ionic solid, I have charged particles, but I can't move. I can't flow. Remember we talked about that in our definitions of a solid, liquid, and gas. So if it's a solid, it's not going to conduct. Okay? So the only way I can fix this is I need to take this solid and either put it in the liquid state, so I need to melt it and put it in the liquid state, or I need to dissolve it. So if I put it in the liquid state or I dissolve it, now my ions, so I have charged particles, now they can move, now they can flow. So in summary, ionic compounds, they do conduct electricity, but only when they're in the liquid state or when they are dissolved in water. Because if it's in the solid state, they're not going to be able to flow. Because to conduct electricity, you have to have charges and it has to flow. Alright, so here's kind of an example. So here's NaCl. This is NaCl as a solid. So if you see it, it's just a chunk of NaCl. And so just solid NaCl. And I take my apparatus here, my conductivity apparatus, and I stick it in the solid. Even though there's charges, because this is a plus, this is a minus, this is a plus, this is a minus, I have charges. For it to conduct electricity, I have to have ions, or charges, and I have to be able to flow. So he has charges, but since he's a solid, he won't flow, so no electricity. But if I take this NaCl and I dump it in water, so aqueous here, AQ, means aqueous, and it means dissolved in water. So if I take my salt and I put it in water, so now I've got some salt water, now you can see I got ions, and they can flow because it's in liquid. So now I conduct electricity. Okay? So ionic compounds conduct electricity, but only if they're dissolved in water or if they are melted so that then they're a liquid themselves. Alright, so now that we've got through all the properties and all of that, now we can actually get to the whole meat of what this chapter is on. So the whole big important part of this chapter is naming formulas and writing formulas. So naming and writing formulas. So the next lecture we're going to start writing some formulas.